So today we want to talk about piecewise functions and, well, algebra limits really. So we have four objectives today, and our four objectives are to do computation with limits, to use algebra to find limits. We're going to do trigonometric limits, and we're going to do limits of piecewise functions. Alright? So in last section, we figured out what a limit is. It's the idea that we're approaching a number and we're trying to squeeze it to get as close as we can to it. So now in this section, we're not doing any of this guessing things. We have precise rules which we can use. Now, here are all of the rules that you need to know. So let's write laws of the limits, or let's write limit laws. And we'll do some examples with these. Okay, so we have some suppositions that we know. The supposition is that C is a real number. F and G exist. And F and G have limits at C. So these are our suppositions. So when we assume these things, the following are true. Firstly is constant rule. Oops, hold on. Firstly is constant rule. The limit of any constant k is the constant itself. And this is for any constant k. And that can be summarized as the limit of a constant is a constant. The second limit law is, of course, limit of a linear function. Limit as x approaches c of x. See, and that should be relatively obvious. The limit of linear function is the value itself. Okay. Next is the multiple rule. the next is the multiple. So the limit of a moment of a constant times the function is the constant times the limit of the function. So rules 1 through 3. Let's continue. Four is the sum and difference rule. So your book on page 61 has these separately, but I will combine them. So, lastly, the limit of a sum is so the limit of a sum or difference is the sum or difference of the limits. Okay. Number 5 is the product rule. The limit of the product is the product of the limits. Then there's rule number 6, which is of course the quotient rule. The limit of a quotient is the quotient of the limits, provided that g of x is not 0. So a limit of the quotient is a quotient of the limits. Okay. Obviously, if the denominator is not 0. Okay, that's about 3 more rules we have. Next is the power rule. The limit of a power is the limit of the power of a function is the power of the limit. And of course, n is a rational number. That's the symbol for rational. So yeah. N is an element of rational numbers, and the limit exists. Let me use the blue once again. As you'll notice, I give a few more rules than what's in the book. I'm combining everything into one kind of theorem. So that you have two more limits to cover in this. Yes. 8 is a limit of a polynomial function. Okay, I'm gonna write found by direct substitution. And of course, p is polynomial function. Last but not least is of course limit of rational function. Limit of rational function, where r of x is equal to f of x over g of x. Actually, limit of rational function found if denominator is not equal to 0. Okay? So this is all the rules. I'll go over it one more time, starting from the beginning. The limit of a constant is a constant. Limit of a linear function is the value itself, whatever c is. Limit of a constant times a function is the constant times the limit of a function. Okay. Limit of a sum or difference of function is the sum or the difference of the limits. This is rule 4. Rule 5 is product rule, which is limit of product is the product of the limits. Rule 6 is the quotient rule. Limit of quotient is quotient of the limits, provided the quotient is not 0. Provided again, denominator is not 0. And then limit of the power is power of the limit. Q is element of rash, and n is element of rational numbers. Limit of polynomial function can be found by direct substitution, and same for rational function, provided the denominator is not 0. Okay, easy enough. So let's do the answer. So let's find the limit of x squared plus 3x minus 4. Now, there's a couple of solutions. So I'm going to give you some solutions to these. Okay, there's 3 different solutions. There's actually 3 different solutions to this. Okay. So solution A is to plug C into f of x. Okay. So we'll plug in C into f of x. So wherever I see x, I replace it with 1. Okay. And so if I plug it in, 1 plus 3 is 4. 4 minus 4 is 0. Okay, that's the quickest one. Solution B, and you can choose the way that's most comfortable for you. Solution D is to use the limit loss. So the limit gets distributed to each of them. So this becomes limit as x approaches 1 of x squared. That's from using the power rule. Plus 3, the limit comes out. Limit as x approaches 1 of x. Right? This is from the constant rule. Minus the limit as x approaches 1 of 4. Okay. And so each of these involves direct substitution. And since limit of a constant is a constant, that just becomes 4. So this becomes 1 squared plus 3 times 1 minus 4. So it's 1 plus 3 minus 4, which is, of course, 0. Still. Lovely, huh? And, of course, well, that's it. There's only 2 real ways to calculate the limit. And then the third way is to do your algebra beforehand. Okay. Your third way is you could have used algebra to factor this. So let's do one more. So solution C is use algebra. So we have the limit as x approaches 1 of x squared plus 3x minus 4. Whenever you do algebra on a problem, you always use the words ALG for algebra. And so we'll factor this. That's 4, 1, 1, 1, minus, plus, minus. So x plus 4, x minus 1. This is, of course, the painful way to do it. Use algebra and the limit laws. And you'll find out that you'll end up having to use this algebra a lot when you're calculating limits, because you're going to end up with rational functions, and those are pains in the butts to do. Okay. So thusly, so if I take and plug in the numbers, right? So if this is 1 plus 4 times 1 minus 1, 0 times 5, which is, of course, 0. And so you end up with the limit as x approaches 1 of 0, which is, of course, 0. Okay. So that's last way to do it. Okay. So 3 different methods for you to choose from. Pick whichever one's most comfortable for you. Now, let's consider a rational function for an example. Alright. Now, in this situation, you always, when you're working with rational functions, you want to factor first, if so far possible. So, when you're working with a rational function, you always want to factor if you can. Okay. So factor if it's possible. If it's not possible, then you'll end up having to use direct substitution probably. Even though I could easily use direct substitution, it's a lot easier to work with the factored form. So again, let's do our algebra on the side. So we have x squared plus x minus 2, x plus 2. Factor it. 1, 1, 2, 1 is x squared plus x minus 2. Factor it. Want positive 1, so positive 2 minus 1. So this becomes x plus 2, x minus 1 over x plus 2. X plus 2's cancel each other. And thusly, as such, we end up with the limit as x approaches 2 of x minus 1, which is 2 minus 1, which is just 1. So when we're working with rational functions, we always want, if possible, to factor it and make it into something good we want to work with. Let's check on the time. How are we doing? How are we doing on time? Okay, 28 minutes, plenty of time. So now, let's go back. And so now I want to get to the second objective, which is of course using algebra to find limits. Now, what happens in a situation when I get 0 in denominator? So let's find the limit as x approaches 3. Square root of x is 3 over not square root of x square root of 3 minus 9. Looks painful, doesn't it? Now, if I plug in 3 into this problem, this right? 3 squared is 9, which makes the denominator 0. So, by direct substitution, 3 minus square root of 3 over 3 squared minus 9 is equal to 3 minus square root of 3 over 0, which is a problem, isn't it? Okay? So, this is a problem. Right? We know that the denominator cannot equal 0, so direct substitution doesn't work in this situation. But what I can do in this situation, once again, is factor the problem. Now, this one looks a little bit more complicated, because if we do my algebra, on this I have x minus square root of 3. This is, of course, difference of squares, x plus 3, x minus 3. Now, you may look at this and go, oh, I can't do that. Not at all. But they did not teach you, of course, during school hours, of course, is how to factor with this situation. Alright, Oops. I had a square root there. Okay, and they certainly didn't teach you how to work with the situation. Square root of 3. We end up with a situation called 0 over 0, which is defined as indeterminate form. Now, since they didn't teach you how to factor this, of course, you can see that this second function right here is a difference of squares. It's just an ugly difference of squares, which we don't normally work with. So this becomes square root of x minus square root of 3 over x plus 3 times square root of x plus square root of 3 times square root of x minus square root of 3. Now I can work this problem. That cancels that, just like it is. And so I end up with, now, so after all that painful work, and algebra-wise, I end up with the limit as x approaches 3 of 1 over x plus 3 square root of x plus square root of 3. I can plug in a number, which in this case is 3. So it's 1 over 3 plus 3, and then square root of 3 plus square root of 3, which is of course 1 over 6 times twice square root of 3. So square root of 3 plus square root of 3 is twice square root of 3. So it's 12 square root of 3, so it's 1 over 12 square root of 3. And then I want to rationalize the denominator as always, so multiply by square root of 3 over square root of 3. So this ends up being square root of 3 over 36. And that's the final answer for that. Painful, isn't it? Now that we've done that, I kind of want to shut up to give you some practice for you to work on. You guys should be able to do this now. So your homework. So read page 61 through 60. Read page 61 through 63. Read page 61 through 63. And on second page, secondly, your homework is read on the next lecture. We'll cover trigonometric identities, and we'll cover squeeze theorem as well. Okay. Since I said half hour is enough for me talking. And go to page 68. Numbers 1 through 3. Five and 6. And then 11 and 12, please. And then, of course, for next lecture, we'll go over more of how to use algebra to solve limits. We'll do trigonometric limits, and we'll do squeeze theorem, hopefully in next video, depending on how much time we have. So this should be enough for you. Good luck.